Today we're talking about sector area. We're talking about the area of a circle, and we're talking about part of a circle's area. Yesterday we talked about circumference around the circle and how to find part of the circumference around the circle. If you want to find the part of it, well, then you need a fractional piece of it, and that fraction is represented in a proportion. So now we're talking about the area and the partial area of a circle. And so what we're doing is using the area formula, pi r squared, but now we're going to set that up as a fractional area. In other words, we're setting up a proportion so that we can find part of a circle. And so when we have a part of a circle's area, we're calling that a sector. So the way you name it is you use the letters, just like you would name an angle. If I were looking at the central angle with center C, with vertex C, I would name this angle ACB. But we're talking about the area formed by the sides of that angle and the edge of the circle. We now call it sector ACB. So that's how you say it, and that's how you write it. So this is a minor sector, so this would be the area of the minor sector, and everything else then would be the major sector. Now these two sectors, the minor plus the major, would total up to the entire circle's area. So for example, if you knew the total circle's area and you knew the minor sector's area, then you could do a subtraction problem to find the difference. You could go total minus the minor equals everything else, which would be the major. Or if you knew the major, you could take the total area, subtract the major, and that would give you everything else, the minor sector. If you are naming the major sector, it actually has the exact same name because this major sector is formed by the sides of the exact same angle. So it can be really confusing. We would call this sector ACB, and the major sector would also be called sector ACB. So we don't really know which one we're talking about just by the notation or the name. So that's why we have to talk about minor sector and major sector. So here is our proportion. Again, we're going to use the area of a sector as the part of the circle's area over the whole. Remember, that's the formula for the area. So we often use like capital A to represent the area of a circle, but that's the pi r squared part. And that's what they're saying here on the left-hand side. You have the partial area over the total area, and on the right-hand side, again, it's a partial arc measure over the total arc measure. And as always, it's 360 degrees around, so that stays the same. So you have these 1, 2, 3 fields that we are having to fill in. So we're using this proportion to either find a missing arc measure or a missing sector area or even a missing area of the total circle. So let's look at a few examples. Notice in this it says find the areas. So we're finding more than one area. It's plural. We're finding the areas of the sectors, right? So again, there's a minor sector and a major sector, and it's asking us to find both. So also keep in mind, your homework is worded the same way. So when you're doing the homework problems, you're not finding only the shaded, but you're also finding the unshaded sector, both the minor and the major, and they should add up to the total. So let's get started. Step number 1, find the total area of the circle, pi r squared, because they give us a radius of 5. There's no particular units assigned to that. So whatever the units are. So 25 pi, that's a decimal value of 78.54. Again, whatever the units are, squared units. And then step number 2, use the proportion here. So we want to start by finding the area of the minor sector, because that's where the angle measures. You see that 63 degrees? That means we know it's 63 degrees around the circle in that arc. That's the arc measure of the formula. So because they're giving us information about the shaded minor sector, that's the area we're going to find first. So this is the minor sector over the total area, which we just figured out here, 78.54. And we'll set that equal to this ratio, the number of degrees around the circle, 63. over the total number of degrees around the circle, 360. Right, so the minor sector is our variable. It's currently being divided by the 78.54, so we're going to multiply both sides by the 78.54. And again, we take that to our calculator, we'll go 63 times the 78.54, take that answer and divide it by 360, and this gives us 13.74. Again, whatever those units are, they're square units. That's only the minor sector. So now we have to find the major sector. And to do that, we could set up another proportion. We would have to use this other angle by going 360 minus 63 degrees. But that takes a little bit longer. It's actually faster if we take the total area and subtract the minor sector's area, and that difference will give us everything else, which will be the major sector. So 64.80 square units. So again, notice we are ending up with really three numbers that represent area. You have the complete area of the whole circle, step number 1. You have the area of the minor sector, that was step number 2. And then we take the difference and we find here in step 3 the area of the major sector. All right, here is another example. Let's take a look at part B. We have a radius of 9 feet. So step number 1, find your area of the circle, which is pi r squared. So pi times 9 squared. So 81 pi will give us 254.47. Step number 2, set up the proportion. We want the sector over the total area. And the shaded sector has the information of the 106 degrees, so that's where we're going to start. It has an arc measure of 106 degrees. So this will be the minor sector over the total area over the, equals to the 106 degrees over the 360 degrees. So again, here is the variable. We want to multiply both sides by the 254.47. And I'm running out of room there, so it's a little bit crunched on the right-hand side. So we will have 254.47 times the 106, all of that divided by the 360. And this is the area, 74.93. Now, the units here are feet, so that means our area is feet squared. And now step 3, find the major sector with a subtraction problem. We'll take the total area, 254.47. We'll subtract the minor, 74.93. And that difference is everything else, 179.54 feet squared. That's the area of the major sector. So now we want to take a look at, again, a few more variations on this, other kinds of proportions that we'll be using where we have to find different variables depending on what the question is asking. So let's take a look at example number 2. Again, find the indicated measure, and notice this extra little detail, the given area. So they're going to give us some information. The given area is for the shaded region. Now they're parking it outside the circle. Here in part A, we have an area of 36.07. That is not the area of the whole circle. According to the directions, it belongs to the minor sector. So label that. That's the minor sector area. What they're asking us to find instead is the area of circle M. M is the center. That's the whole circle. So they're asking us for the total area. So we're starting off with the small shaded sector, and we're working backwards to find the total area. So we're going to jump right into that proportion because the minor sector always goes here on the top. That's the 36.07 centimeters squared. And the area of the circle goes on the bottom, and that's what we're trying to find. So capital A for the area of our circle. That's the variable we're solving for. Here we have 58 degrees in that minor sector's region, and that'll be set over 360. So we need to cross multiply because the variable is in the bottom. So 58 times A equals 36.07 times 360. Then divide both sides by the 58 to get the variable by itself. So we'll type this in our calculator, and we get a result of 223.88. And again, check the units there, centimeters squared, so we also need centimeters squared. Notice that our answer is a lot bigger than the area they gave us, and that makes sense because the area they gave us was just of a small region, the minor sector, and they're asking us to find the entire area, so we set up the proportion correctly. If we had ended up with an area that was much smaller than 36, that would be a red flag saying, wait a minute, you set your proportion up wrong. Try something else. All right, here's another variation on this. They're not asking for the area, they're asking for a diameter. Well, the diameter goes all the way across. And if you want a diameter, you first have to find a radius. Well, we don't have a radius. So if we want to find a radius, we need the area of a circle. Well, we don't have the area of a circle. We have an area of the shaded region, which is here. Notice that is more than half of a circle, so that's not a minor sector. That's a major sector, which is fine. We can still use the proportion. But if we have the area for the major sector, then that means we also need an angle for the major sector, or an arc measure, and the information they're giving us is of the minor sector on the left-hand side. That 109 is not helping us. We need to know this many degrees on the right side. The 109 is in the wrong place. So let's go 360, so that's all the way around, minus the 109 that they gave us on the left side. And this will give us the number of degrees on the right side, everything else. So that's what we have here. That's 251 degrees, which means this arc measure is 251 degrees. So now that we have both the area for the shaded side and an arc measure for the shaded side, we're ready to set up our proportion. They're giving us a major sector area of 72.39 over the area of the circle, which we don't know, so again, capital A for that. Here we have 251 degrees. Again, don't use the 109, that's on the wrong side. You need the 251 on the right side because that matches the shaded area sector that they gave us, over the 360. And again, we have to cross multiply. So 251 times the area equals 72.39 times 360. Divide away the 251. The area of the circle is, so we type that into our calculator, we get 103.83. Now we haven't answered the question yet because the question is find the diameter of the circle. But if we want the diameter, we need the radius. So we're going to use this total area of the circle and work backwards to find the missing radius. So now we're going to use pi r squared, right? This is the area. We know that equals pi r squared. So area is 103.83. That equals pi r squared. So let's start by dividing both sides by pi. We're solving for the radius here. So the radius squared is 33.05. Now we take the square root of both sides to get the radius all by itself, and the radius is 5.75. Now that we have the radius, we'll double that to get the diameter. So my diameter is 11.50, and that's in feet. So these two problems are independent of each other, right? Different pictures, different numbers. In both cases, we were working to solve for the missing area of the circle. Here in part B, we had a few extra steps as we had to take the area of the circle and then work to find the missing radius, and then from there the diameter. But here in example 3, what's different is we really have a series of 4 questions that are all related to the exact same picture. So they're going to kind of guide us through some of these steps, finding some of the pieces that we need. And again, part of the challenge is trying to figure out, do we need to use a proportion or not? And if we don't need a proportion, what else could we use? All right, so it says the area of this circle R is at the center. The area is 295.52, that's in inches squared. And the area of the sector of PRQ is 55. Now remember, this doesn't really clarify whether we're talking about the minor sector or the major sector. So you want to compare these numbers. If the total area is 295, rounded that up to 300, and the sector area they're giving us is 55, that's less than half. So that is going to be the minor sectors area. So first, let's find the radius of the circle. It's not printed here in the diagram. Does that mean I need a proportion? No, it doesn't, because remember, you can use area equals pi r squared, and they're giving us the area. So 295.52 is the area. Let's solve backwards for the missing radius. Start by dividing both sides by pi. So r squared is 94.07, and then we'll take the square root of both sides. 9.70, and that's in inches. Now, let's find the circumference of the circle. Okay, do I need a proportion for that? No, because I have a radius. Circumference is 2 pi r, and the radius that we got on the previous step is 9.70. Again, that's in inches, so my answer here will be in inches. 60.95, and that's in inches. All right. Part C, we want to find the measure of arc PQ. So now we're talking about how many degrees are around the circle between P and Q. Do I need a proportion here? Yes, because we don't have a central angle. We can't just transfer the information. We have to calculate this directly. So we're going to set up a proportion. So we have to figure out what exactly are we putting in here. We know we have 360 degrees here on the bottom right. And this measure of an arc, a measure is always in degrees. So that means this is our variable. So this is the measure of the arc PQ that they're asking us to find. That means we must have some numbers already provided or that we calculated that will allow us to be able to put in on the left-hand side of this proportion. Do we have the sector area of PQ, right? So we're trying to figure out how many degrees are in PQ, which is here. Did they give us a sector area of that? Yes, they did. This is the minor sector area. So they're already giving us this area. I'm shading it in so you can kind of see that. The number of degrees that we're trying to find is of the sector that we already have this information. So yeah, we can use the 55. So here we have our 55 square inches, and that means we need the total area of the circle, which they also gave us here as well. That's the 295, 52 square inches. And you can see they have the same unit, so inches squares cancel out. That means degrees are the only thing that is remaining, and that's what our answer will be. So let's get the variable by itself. I'm going to multiply both sides by 360. So the measure of this arc PQ will be 67 degrees. So now we know this is 67 degrees. So now they're asking us, as this final step, to find the length of the arc PQ. So we're still talking about arc PQ, but not the number of degrees. We want to know the length, and length is measured in inches. So we want to know how many inches it around. So that means we want to use this length as our variable. So this is the length of the arc, and I'll just write it as arc PQ like that. And because that's a length, in the bottom of this we also need a length. We can't use area. You can't mix and match length and area. Length goes with length and area goes with area. So I have a length on the top that I'm trying to find, so I need a length on the bottom. So what length would that be? Well, it's always the total length. We found that here in the previous part B. So that's the circumference. Your circumference is the total length, and we calculated that as 60.95. And again, for the number of degrees, we know we have the 360 on the bottom. That means we need a number of degrees here in the top right. And the length of PQ is what we're trying to find. And we have degrees for also PQ. So that 67 degrees is what we are using because they're both from the same space, the same region. All right, let's get our variable by itself. We're going to multiply both sides by that 60.95. And our units are in inches, 11.34. All right, so here's a little bit of an extra. This is a little bit of a bonus here. Notice you have a circle there, okay? And we're trying to take this square peg and push it inside the circle, right? So maybe you've heard this before. You can't fit a square peg in a round hole, all right? I mean, you can't force something to happen, right? Because they are apparently of two different shapes. But mathematically, you can fit a square peg in a round hole. It just won't completely fill the hole. So instead of filling up the entire area of the circle, we're just using the area of the outline of the square peg and kind of squeezing it. We're inscribing it in the circle, right? Because there's your square and it's touching the circle's edge. So we're really inscribing a square in a circle. So let's just pretend we have a hole with a 4-inch diameter. So that's your circle. It has a 4-inch diameter. And then we're trying to inscribe a square into that space. So this might look more rectangular, but it's supposed to be a square. And what I'm trying to do is I'm trying to draw a diameter of the circle that is also a diagonal of the square. Notice we have a right angle. So because that's a square, again, it looks like a rectangle, but because it's a square base, that's a square, that means you have 4 congruent sides. So take a look at what kind of a triangle you have right there. You have a right triangle with a hypotenuse that is 4 inches. So what we're asking is, what is this width of the largest square that could fit inside that circle? How wide is that? It's also the same as the height, right? That's also the same size. So we could use Pythagorean theorem, a squared plus b squared equals c squared. That's one method that we have, right? So w squared plus w squared is 2w squared. Divide both sides by 2. And then take the square root of both sides. And so we have root 8. Now you might also remember that this is a 45, 45, 90 triangle. And so if you think of it that way, if you think of it as a 45, 45, 90 triangle, then we have these special rules. I mean, we know the hypotenuse equals leg times root 2. And so you could have used that approach. The hypotenuse is, it's 4. And the leg is the width that we're trying to find. You could divide both sides by root 2, and you have to rationalize the denominator. Here we're going to simplify the radical right away. So we'll just factor that into 4 times 2, and our width is going to be 2 root 2 in inches. So that's about 2.83 inches. So that's the exact length. We found that our square peg would have to have an exact length of 2.2 inches. What is the approximate width? Well, if we take that to the calculator, it's about 2.83.